takes place, then it's going to drive the motor. But for our case, the gas that we use is acetylene. It doesn't have it has much pressure on just driving the turbines, but in terms of heat, it's not that good. That's why there is soot. Actually, yesterday we tried to use butene, but actually the regulator wasn't good enough for regulating the pressure. So it was like blowing up the flame. It was a blue flame rather than this, but it was good. But it won't take long. Then the whole thing gets hotter, and as to our material that we used couldn't that much withstand for a long time heat.
What is the efficiency of your turbine?
Efficiency actually is just we couldn't calculate the efficiency, because the type of our project was just a teaching model. Yeah, but we did our level best to not just with just a teaching model. Instead, we came with an idea of making just like a prototype.
You say that you put a supply there.
Yeah.
You drive the small motor there for initialization.
Yeah.
Then thereafter, after the burning, the combustion takes place there. This mechanism runs the generator itself.
Yeah.
Can you test that after it have burnt?
Yeah.
Try to disconnect the supply to
Yeah, as I told you earlier that the gas that we used is not good enough for combustion, etc.
Okay.
Yeah.
Therefore, the rotation I see there, I think, is from the supply.
Yeah, it's from the supply, but there is a certain kind of increase of the rotation due to the combustion of the gases.
So you use the DC at the starter?
Yeah.
As far as who did this?
We did this.
This casing and the blades.
Yeah.
Okay.
Can you run this without? Can you run this without? One of the weakness that he did it.
You are one of them. Okay. That's fine.
What type of bearings are you using?
We use just a normal bearings, from a bicycle hub, the front hub of the bicycle. Yeah. Just a ball bearing.
It is in the center, in a combustion chamber, held by the hub supporter. 6 is this nut. Yeah, hub is 16 in the hub supporter, 16 is this nut to the case, and hub to the center, carrying this shaft, which carries the blades rotates. But we use the revolution is maintained by the shaft actually.
But why did you add this? Until this is enough? The screws?
Okay. The issue of a jet engine is, first you have to compress the air, the inflow of the air, you have to compress it.
Okay.
So, but in order to attain that, you'll have a series of blades, which are as a dynamic blade as this, the first one. The following should be a stationary. This is the stationary blade. If we open, we're going to show you the pictures that the after of this dynamic blade there is a stationary blade. Then from there, then we have another dynamic blade, then a stationary blade. For our case, this is it has four blades, which stationary, a pair of it, which is a stationary dynamic, forms is called a stage. So for our engine, it's just a 2-stage engine. For the commercial engine, it's almost 13 stage, which has almost 26 blades, a series of dynamic and stationary blades. So even though the compression and the thrust wasn't that good, because it's a two-stage engine, we couldn't attain that. But if we could get a lot of these blades, we could attain much thrust. And on the other hand, we could use, this is they call them the axial blades. The axial blades, just normally we just cut it from the blades, then we just bend it to a certain angle, which is between 38 to 41. But then we could use radial blades. The radial blades are the one which are found in the turbo in the cars, as you can see. They are structurally efficiency, and they are much good compared to the axial blades. According to the theory, it says like a 6-stage engine is almost equal to one of the radial blade. So for our case, it hasn't even reached one of the radial blade. We intend to use radial blade furthermore when we do another thing of this kind.
Therefore, you say it's 2-stage. This is first stage with the fixed one.
Yeah.
And here there is dynamic. Then
And
this fixes another fixed.
Yeah.
Now, what are these screws for?
These are the supporters. Between here, there is a hub.
Okay.
So the hub can, in order to mount it and to centralize at the center of this casing, we had to make the supporters to support the hub. Then later on, from here, we are having the turbines, the blades. Actually, we just kept 2 of them. These are the one which drives the other blades, because they are connected via the same shaft. So as the gas ignites and explodes, they drive the turbines. And since the turbines are just connected via the same shaft, they are going to drive the compressors. That's how it works, and the system goes smoothly like that. And on the other hand, we had to make this the cone. The cone,
Why did you decide to make it like that?
yeah, we decided to make it that way because actually we were required to use TIG welding to weld this kind of stainless steel. So for our case here in school, in the institute, we don't have TIG welding. So we tried the alternative way, as in to connect via the plates and just mechanical fastening using just the bolts and nuts.
Normal welding process can't weld this?
It can't, because the thickness is just 1 millimeter. And it's a stainless steel.
Gas welding?
TIG welding, it's tungsten inlet gas welding. It's a welding which has a torch, which has a tungsten rod, which is non-consumable, it doesn't finish. And the gas which is used is argon. So the argon is ignited via the tungsten rod, and it has a very, very high efficiency, even especially for it's used for welding the small thickness.
How can we weld if the electrode is not consumable?
Actually, you have just to feed, or sometimes if the thickness, if the gap between the welding joint is so small, we don't need to use the filament.
Why don't you use the normal gas
They
welding?
use filament.
Yeah.
There's a question. Why
don't you use normal gas welding?
Why did
Normal oxyacetylene, yeah?
oxyacetylene? Normally the TIG welding, when you use TIG welding, the heat affected zone, the joint itself, it becomes more strength than the material itself. For the case of our case, heat we can't avoid by any means heat here. For the TIG, because as we are using here, we're using acetylene. If we could use the acetylene and we are going to use the normal fluxes that we have here, it might just blow up, or maybe just the joint might be that weak, not that much of strength. In another way, we could find
Maybe we
just
have more time to ask when we after presentation. So
Okay.
the device you are going to be assessed by your supervisor. So